Yeah, sorry for the delay. There was some technical issues. I hope the video in this presentation works, but let's see how it goes. So yeah, today I'll be introducing about our kind of Autoware Foundations project called OpenAD Kit. So let me go through the slides. So before I explain about OpenAD Kit, I would like to explain briefly about myself. So I'm Ryohsuke Mitsudome. So for people who doesn't know me, I'm currently working as the architect in Tier 4. So I kind of design about the product in the Tier 4, which is a startup for autonomous driving in Japan. But also at the same time, I also have a position within the organization called the Autoware Foundation, and in here, I basically have a position as the chair of the technical steering committee. So I basically look for any kind of support or kind of help for all the kind of contributors to this open source autonomous driving stack hosted by this foundation. And actually, the autonomous driving stack called Autoware is used in my own company, Tier 4, as well. So that's my background. So yeah, let me also share some background about what we develop. So both within Tier 4 and Autoware Foundation, I basically work for development of the Autoware. This is the full stack open source autonomous driving. It was originally open sourced in 2015, but since then we've been doing a lot of version updates. For example, from migrating from ROS 1 to ROS 2, we've also done a lot of architecture kind of changes. And we've been kind of developing on and on throughout the open source community. So originally, this was owned by Nagoya University from the laboratory spinoff. But in 2019, we decided to kind of maintain this as the foundation. Organized by multiple organizations, so that we have fully kind of open source community rather than the open source owned by a single company or university. So some of the kind of key points about this structure with our Autoware is that it's, like I said, it's completely open source and it's running on a framework called ROS, now in ROS 2. And this system was kind of applied to different vehicles and different sensor setups. So it was meant to be developed for different use cases and different hardwares rather than kind of designed for specific hardware sets. Like I said, and it's also governed by an independent organization, and it's completely free for use under Apache 2.0. So yeah, these are some of the images showing where kind of the Autoware was deployed. So these are some of the kind of known projects that was kind of done through the Autoware Foundation's members. Obviously, it's open source, so it could be used by anywhere else. But some examples. So there was also in the last presentation, we also mentioned about Indie Autonomous Challenge, but we also kind of sponsored this event and had some teams using Autoware as a kind of base to control the vehicle. We also done some test demos in the US, in Japan, in Europe, and also in China as well. Using all these kind of various vehicles, including like race cars, bus, shuttle kind of vehicles, EVs, demo cars, kind of taxi-like vehicles, and so on. And we also have like these kind of RC cars for education as well. So just as a kind of brief overall roadmap, we've been kind of targeting to develop features for certain kind of use cases each year to kind of evolve the functions. We started with autonomous valet parking in the closed area so that we have like simple ODDs. And then the next year we went to cargo delivery with half kind of private area. And then we moved on to the bus ODD where it's public but with fixed route. And now we're targeting for the robotaxi use cases, which includes both dense urban driving and the highway driving as well, basically from curb to curb. For example, from driving from your home to the airport, for example. So yeah, this is just a demo video. Let's see if it works, hopefully. Okay, not. Sorry. So yeah, unfortunately the video doesn't work and my PC didn't work as well. So I'm not gonna be able to show the video. But basically, we've done a demo in Turkey. By the member company called Ryohsuke and the Autoware Foundation. And this wasn't really a project for a customer, but it was purely for this open source project. So Ryohsuke was kindly raising their hands to provide us the test course and their vehicle, this bus. To basically demonstrate the capability of our open source software to apply to these bus use cases. And we've done the demo last year, and we've also done another kind of bus demo with a company called Itri in Taiwan to basically show that our software is not kind of made for specific hardware, but it can be applied for different kind of hardware in different places. So yeah, if you're interested, the demo video is also available on YouTube. So if you search for like Autoware bus ODD demo, you probably can kind of find it out on the net. And this was also a video, but probably it doesn't work. But anyways, yeah, okay, oh, sorry. Presentation. I think I pressed the wrong button. Okay. So, like I said, since we were kind of over with the bus ODD project, we moved on to the next phase, robotaxi development. So for this, we targeted for dense urban driving. We've done heavy kind of a sprint, a half-year sprint over the last 6 months, and we've done a lot of improvements, both around the actual features of Autoware, including like perception, localization, and planning. But also, we've also done a lot of improvements with our toolings to make sure that these features are developed using more sophisticated engineering development process. So this includes like a development of our simulation as well. So this is based on Unity based simulation, and we provided we basically prepared like the E2E, I mean the digital twin environment to basically test our features with defined kind of scenarios to actually test our Autoware's functionality to drive within cities. So yeah, that was the overview of the Autoware, and I will also go through a little bit about our organization, Autoware Foundation. So Autoware Foundation, like I said, it's independent organization formed by multiple companies and universities and research institutes. But our kind of philosophy is that we would like to build this ecosystem among different groups. In a society to make sure that we can provide sustainable kind of autonomous driving service through kind of partnerships between different regions. So in the Autoware Foundation, we mainly kind of focus on development of the autonomous driving kind of features. But if we kind of think about delivering this into actual service, we basically have to make sure that we have good relationship with like local governments. We would like to make sure that we have standards to make sure that we can communicate properly with infrastructures, and we also have to make sure that we have good APIs designed for different service providers to communicate with Autoware through their kind of cloud to make sure that these fleets are managed properly as well. So in order to kind of make these standardization and partnerships, we formed the Autoware Foundation and kind of communicate with different groups of people within the industry to make sure that this kind of moves on. So these are some of the example kind of organizations that belongs to the Autoware Foundation. So the premium members, we currently have 19 organizations. We have different companies from all over the world, from Turkey, Europe, US, China, Korean companies. We also have like the big companies like ARM, AWS, and we also have like different kind of sensor vendors. So not only for like autonomous driving software as well, but we also have partners with the members joining from the hardware and also like service providers to make sure that we cover all the necessary technologies to run the service. We also have a lot of partnerships with the other open source organizations like Eclipse Foundation, Linux Foundation, MIH, a group called SOFI, to achieve the software-defined vehicle approach. to make sure that we have a proper kind of deployment on available. So these are some of the explanation. So as Autoware Foundation, we're basically developing the full stack autonomous driving features. We have Sophie, who's focusing on developing a software framework to basically abstract the hardwares from the software to make sure that all the workloads are containerized and deployed from cloud to edge with the same system parity. We have eSync Alliance as well, which basically focus more on the OTA updates to have more secure updates from the cloud to the vehicle. We have MH, who's focusing on more of a defining open specification of like the hardware sets for EV vehicles. So we have these partnerships to kind of discuss about what would be the best way to develop the software-defined vehicles as well. Yeah, I might want to skip some of the slides to make sure that we, for the interest of time. So let me then move on to a bit more description about how we achieve these software-defined vehicles. So in order to comply with the concept of software-defined vehicles, we actually kind of designed the Autoware to make sure that it can work as a platform, which is basically customizable and flexible and extensible for different use cases, and also makes it more kind of feasible for cloud kind of native development process. So for this, we kind of took the approach to make sure that we have autonomous driving vehicles defined in terms of components, shown in this diagram here. So these are kind of typical diagram that use as kind of most top-level component breakups of Autoware. So we have sensing hardwares. These sensing hardwares are abstracted through our sensor drivers to to make sure that we have converted into the ROS topic messages. And these informations are passed down to localization and perception, which will use like map data, vehicle information to basically do recognition of the surroundings environments, and then make sure that these information is passed down to planning, and then the planning will calculate the trajectory, and the trajectory will be passed down to control, which will basically calculate the actual actuation commands that will be passed down to the vehicle interface to make sure that this vehicle will follow the trajectory that is planned by the planning features. So when we design this architecture, we have a lot of reviews to make sure that these interfaces, like the arrows here, so we want to make sure that these interfaces between these components are made properly, so that these components are isolated as much as possible. But at the same time, we obviously don't want to drop off the performance. So we always can think about the good kind of balance between the performance and the system isolation to make sure that we have a feasible kind of architecture for different users. Then for these, just to explain a bit more, so these high-level components, these are also further break down into smaller modules. So we have these hierarchical architecture. So for example, the planning, it will have like the global planners, and we have like the different modules for lane following, parking, and so on to kind of to be applied for different scenes. For perception, these are broken down into like the object recognition and traffic light detection. And each of these are also further broken down into like detection, tracking, prediction modules, so that these kind of modules are modularized properly. And the merit of making these hierarchical modular approach is that whenever people would like to kind of apply their own product to kind of communicate with Autoware, so some company might want to just develop localization rather than kind of building the full stack on their own. So in that case, people can just focus on developing their localization feature and just care about the adaptation to these interfaces that is defined by Autoware to make sure that it communicates with the rest of our stack to build a full working system using their localization features. So this is especially a merit to people who study in universities, for example. People would like to kind of customize Autoware or replace some of the modules within Autoware to basically do the research on the state-of-the-art features for different modules within the autonomous driving stack. So yes, so by this modular architecture, we kind of utilize this to make sure that we can achieve the automated development as software-defined vehicles. So for our kind of concept of software-defined vehicle, what we kind of see as a vision is that we want to make sure that we have Autoware deployed to the actual real vehicle, which will be driving around the cities. But while it drives around, it will collect the data and send to the cloud. And these kind of cloud are annotated and used for trainings to update the modules. And once those kind of trainings are additional kind of modifications are done, we want to make sure that these updated features are tested on the cloud simulation and with basically the same, using the similar architecture hardware system parity in the cloud side, and then basically deploy the same kind of software that was tested on the simulation cloud to the real vehicle through OTA to have this continuous development of autonomous driving in the cities. I've explained that. So for this, we actually work closely with a group called SOFI. So the SOFI is a group which was initiated by ARM. So their focus is to basically create specifications and reference implementation, which will abstract the hardware from the domain-specific applications. So for example, Autoware. This kind of SOFI, they're also made open source. And as Autoware Foundation, we use their kind of deliverables to test our kind of autonomous driving features to see if it works on top of their SOFI framework to make sure that it can abstract the underlying OS and the hardware to be used in the actual product. So like I said, the key thing is that we always want to make sure that we have system parity between the cloud and the edge. So for example, if we have ARM-based kind of ECU running on the edge device, then we also want to make sure that we are testing our kind of features on the cloud using the same kind of ECU architecture and so on. If this is composed of multiple kind of ECUs, then we also want to make sure that those are also replicated on the cloud to do the system testing. But at least and on the cloud, we also run EWOL, so they're SOFI's reference implementation to abstract these layers to basically abstract the hardware and run Autoware on top of this EWOL framework to test the features of Autoware. So last year in CES demo, we've done tests using some of the components within the Autoware. So the planning and control and simulator modules within the Autoware to do some demos of the autonomous driving features. I think I have a feature here. So the demo that we did was that so this is also just an image, but for the demo purpose, we just wanted to keep some simple kind of scenarios. So we kind of had we created a scenario to kind of test features to demonstrate the capability of like the cloud native development to make sure that we have a proper OTA to update the autonomous driving features. So before the Autoware OTA update, we kind of we prepared a customized version of Autoware planning modules, which will fail on purpose to first show that it doesn't work at before the OTA happens, over the air updates happens. So we had this NPC produced in the middle of the lane through the simulation, and basically initially the Autoware parameters are tuned so that it will not be able to avoid this NPC on the lane. So before the OTA, Autoware will just get stuck when it sees the NPC on the middle of the road. But the thing is that we've had all the partners within the Autoware Foundation to kind of provide us the tools to kind of do the CI/CD tests and updates to kind of make the updates on these planning modules only, so that through the OTA service, we were able to kind of update the planning component only rather than just deploying all the full stack again to make sure that we have minimal viable features updated on the edge device to make sure that these planning modules are updated to make sure that I can avoid these NPCs after the update. So these are the demo that we did in the last year's demo. And what we're planning at the moment as this year's target is that we wanted to have more granular containerized workloads running on top of this EVO this year. So we're trying to make sure that these perception, localization, planning, control, and VTEX components and Autoware are kind of containerized as separate containers so that we have more kind of granular containers to be deployed to the system. And additionally, we also are trying to make sure that we can also deploy this against heterogeneous compute platforms where we have high compute ECUs and safety compute systems to basically run like the real-time operation of controls to make sure that we have safety control of the vehicle. So this, again, is these abstractions are mainly kind of held by the work of the Sophie, but at the end of this year's demo, we're trying to make sure that we can kind of have all the achievements that's done by the Sophie and all the achievements done by the Autoware to make sure that they are integrated together and work out of the box to make sure that it supports these heterogeneous platforms running these modular autonomous driving stacks. And in the end, what our target as end vision is that we want to make sure that we have all these kind of complex, I'm not going to go into the details, but we have all these kind of complex ECUs running on the edge, but having our workloads running on top of these both the high computing systems and like safety islands. With isolated modules, and we want to make sure that these are connected to the cloud to make sure that we have continuous kind of cloud-native development rather than like the old days traditional kind of development process where we actually go to the site and do the debugging. So yeah, at the end, I just want to kind of share you how we're kind of developing these actual kind of OpenAD-Kit modules. So within the Autoware Foundation, we have different working groups to work on these topics. The main working group is the OpenAD working group. This working group kind of leads overall kind of architecture design and the communication with Sophie and other kind of alliances. In the meantime, we also have like a reference design working group to basically discuss the reference hardware that we kind of deploy this OpenAD-Kit to. And we also have like API working group, which will focus on the actual design of the interface, which will be used to communicate between these isolated modules that I explained earlier to make sure that we have a good interface to be used between these modules. So these working groups, they're open to anyone to join. You don't have to be a member of Autoware Foundation to join the call and join the discussion. So if you're interested, you're always welcome to kind of jump in from like Autoware website. We have a page called Join Our Working Groups, and you can just find a meeting link from there. So yeah, if you're interested, always feel free to kind of join us. That's, I guess, all my presentation. So thank you for listening.